Lagrange points are spots in space between two objects where one is orbiting the other. Objects at the Lagrange points will stay stationary relative to the orbiting object. There are 5 different Lagrange points. We will use the Earth and Sun to explain these Lagrange points. Objects closer to the Sun orbit it faster, but at Lagrange point 1, an object can match the speed of Earth. This is because the pullback from the Earth works against the Sun's gravity. This effect makes the object act like it's orbiting a smaller star. With less mass pulling it down, the object can orbit slower. The result is that an object can balance perfectly between the Earth and Sun. A problem with this point is that it's unstable. Objects at Lagrange point 1 are like acrobats trying to balance on a tightrope. As a result, the only things that can inhabit Lagrange point 1 are satellites that can make course corrections as they lose their balance. Lagrange point 1 is a great spot for satellites. They get a constant view of the light side of Earth. On the other side of Earth is Lagrange point 2. At this point, the combined gravity from the Earth and Sun make it act like it's orbiting a heavier star. This makes it orbit at the same speed of Earth instead of a slower speed that it should. Basically, Lagrange point 2 is the opposite of Lagrange point 1. Again, this point is unstable. This means that only satellites can inhabit this spot. Satellites at Lagrange point 2 would get a constant night view of Earth. On the opposite side of the Sun is Lagrange point 3. This point is slightly farther out than the Earth's orbit, but because of the Earth on the opposite side of the Sun adding a slight tug, the object will orbit as fast as Earth. Again, this Lagrange point is unstable, and scientists have yet to find it necessary to put satellites there, so it remains empty save for interplanetary dust. Lagrange points 4 and 5 are 60 degrees ahead of and behind Earth in its orbit. This forms an equilateral triangle with each object at a vertex. This means that the Lagrange point object is an equal distance from the Earth and Sun. The result is a gravitational effect that causes the object to be pulled toward the center of mass of the Earth and Sun. Since both the Earth and the Sun orbit their shared center of mass, and this new object is also doing that, they stay in sync. Lagrange points 4 and 5 are stable. Rather than being a tightrope that is easy to fall off of, they are like a big bowl pulling stuff in. Because of this, all of the gas giants have huge clouds of asteroids orbiting in front of and behind them called Trojan asteroids. Even Earth has a Trojan asteroid. There are also some satellites in these locations. For example, the Stereo A and B crafts are identical spacecrafts at Lagrange points 4 and 5. These crafts are studying the Sun and coronal mass ejections. These points are very useful for many things. The Lagrange points 4 and 5 could be used to communicate with space probes that are on the opposite side of the Sun from Earth. Also, the Lagrange point 3 could be used for detecting stellar parallax. Stellar parallax uses the slight shift in location of stars throughout the year to tell their distance. The problem with this is that you need to take observations 6 months apart. With the Lagrange point 3, the observation could be instantaneous. Space colonies might want to be located at the Lagrange points because of their link to home. Another use could be to give Mars a magnetic field. If we put a big enough magnet at the Martian Lagrange point 1, then it would shield Mars from solar radiation, making it more habitable. Overall, the Lagrange points are delicately placed points in space where gravity comes to an equilibrium and allows an object to stay in place relative to other orbiting bodies.